Our next speaker is Dr. Eugene Steinberg. Dr. Steinberg is a technical fellow and founding engineer at Grid Dynamics. As a principal architect and consultant, Eugene has delivered some of the largest Grid Dynamics programs, from inception to production to maturing. He has many interests, including information retrieval, e-commerce and enterprise search, natural language processing, computer vision, general science, and the art of building scalable distributed systems. Eugene earned a PhD in applied math from Saratov State University. Please welcome Dr. Steinberg.
Okay, today I will talk about search engines. So can I have a quick show of hands? Who is familiar with search engines in general? Oh wow! Like I have a crowd of data scientists. I know this guy. He's good at that. So very quickly about myself. Like you had a grand introduction. I've been working with search engines for more than 7 years by now in different capacity. We've built search engines for pretty much every big name in the e-commerce product discovery industry. People like Macy's, Kohl's, you name it. If you search in their catalog, you're pretty much dealing with our code. So yeah, this is a nice picture of me with a shark. I'm amateur diver. Today we will be talking about the evolution of search engines. So we will be talking about how the search engines over just the last 20 years evolved from a pretty simple yet very, very fast token machines to something which really strives to really understand the meaning of the queries which you are sending to them and the meaning and semantics which is contained inside the documents which you are searching upon. So this understanding of meaning, this is a thing which many in the industry call semantic search, is the holy grail of search engines. How to make sure that you're not just trying to match words to words. How do you approach the matching meaning to meaning? So we will be talking about that today. But first, let's get like rewind 20 years back, and we'll see where the search engines were. Maybe even not 20 years, maybe it's like 10 years back. And this was the state-of-the-art, pretty much created with popular open source search engines like Lucene, Solr, Elasticsearch, Fast, Endeca. All those search engines were fundamentally based on the same very simple principle. We are matching by words, and we are ranking the resulting documents by statistics, by frequency. So the fundamental data structure behind the search engines is inverted index. An inverted index is extremely powerful concept which allows you to really fast search across millions and millions of documents and then rank the results according to statistics of how frequently you see a particular term in a particular document and how frequently is this term occurs in the whole corpus of documents which you're looking for. Those are famous algorithms like TF-IDF, BM25, which are the golden standard for the industry. Even right now, many data scientists are using those kind of feature encoding when they're dealing with their necessity to embed some of the text. You often like just enumerate your terms when you start building some basic statistics, and those statistics work surprisingly well even today, even like 20 years back. So we've dealt with such systems a lot with e-commerce industry, and this is like an example from e-commerce. But I will be also talking about the challenges which usually occur. And challenges here is that words does not represent intent. The human language is infinitely more complicated than words. The same word, like usually search engineers often say like there are only two problems with search engines, like there is a synonymy and polysemy, which means like the same word may mean different things, and the same thing can be represented by a bunch of different ways. And a good search engine have to deal with that somehow. So, and the second problem is that frequency is not relevance. It's correlated with relevance to some extent, but it's not a very good proxy for that. For example, in the commerce industry, if you have like traditional TF-IDF model will say okay, like this document is much more important than another document because the word jeans is repeated 20 times in that. But maybe there is just another very important document or product which contains jeans only once in its product type. But does it become any less relevant? No. The answer is no. So that's why in e-commerce industry, people started to go beyond the full text search. And going beyond full text search means that you're going into a new thing, which is not a new thing anymore, which is called a concept search. So how do we go beyond just the words into things? How do we start matching things inside the documents instead of words? And by things, I mean concepts. So people started to work a lot with a knowledge base and knowledge graphs. So those are the data structures which contain the information about what collocations of words, what compound words mean different things, and how the words have to be interpreted in a particular context. Because, for example, pink rose is not just a pink and rose, and it's not a color, it's a brand. And this is a thing which usually fools your search engine when you're starting to search for such things. Calvin Klein jeans is not about jeans, it's a brand. Silver jeans is also not a color of jeans, it's a brand. So those kind of things you have to capture in your knowledge base, and then you have to be very efficient in the finding these concepts in the knowledge base, and then interpreting your query, parsing your query intelligently so that you can build a different hypothesis about how a particular query can be interpreted, and then you're able to rank those hypotheses. People started to build all kinds of merchandising systems on top of the results to actually embed business signals, because if you're just searching for handbag, there are 800 handbags in the catalog. How do you score them? You can search engine by itself, by counting words, search engine is unable to score them because everything is a handbag at the end of the day. So that's when you started to embed all kinds of business statistics, like what is the profit margin? What is the sales numbers for this particular product? What is the recency and newness of this particular product? And many, many other business signals are embedded into the pretty complicated scoring formulas out there. However, this approach also has the same flaws. Concepts not always represent the true customer intent. There are situations when customer is looking for some particular things which do not match well in the concepts. Most importantly, very often we have a problem when something which customer has typed does not exist in our data at all. It doesn't exist in our catalog, it doesn't exist in our knowledge base. What to do with that? And pretty much before about 5 years from now, like in the past, there was no good way of dealing with that until machine learning comes. And machine learning allows you to start leveraging your data in a much more sophisticated and useful way. So the next step in the advancements of the search engines started with the leveraging of machine learning algorithms to help your search engines with generating more useful data for them, with generating of more useful tokens, and helping with things like linguistic mining. Because by using the analysis of your data with certain machine learning algorithms, you are able to find the collocations of terms which are usual for your product. It helps you to leverage it and augment your knowledge graph. You are able to automatically, by using supervised learning, start to attribute your products based on the data which contained in the images using the CNNs and all this kind of beautiful art of understanding the images, as well as the text, which is usually supplied with the products. You also are now able to start clustering your products in the vector space. And by clustering your products, you give your merchandisers, your business team, a very powerful tool to very quickly perform a mass edit of your products. So like everything here is good for Halloween. Everything here is good for cocktail party. This is much easier and much faster than just sift through all your kind of 8,000 dresses in the catalog and try to say, okay, is it good for Halloween? Is it good for cocktail party? Things like extracting salient features. Things like taking those customer reviews, taking those product descriptions, and extracting the pieces of information from this unstructured text which can be embedded as an structured attributes, and search engine now will be able to match on those in much more precise way, because if you will just try to search inside the unstructured text, you will have huge amount of false positives that will drown your customer in the irrelevant results. So another very important zone is leveraging customer behavior. So this is the situation when we use a clickstream as a proxy to relevance. We are trying to build a clickstream models which say, okay, like for this particular query, this is the set of products which is most relevant. Now let's try to learn. Let's try to automatically derive this formula by which we have to combine the attributes of our products in such a way that we will achieve the highest click-through ratio. And we will have things like intent classification, because in many situations, customers are even not looking for products. Sometimes we are asking, okay, like what is the closing time of my stores? Or how do I pay my bill? Or do you support kind of buy online, pick up in store? So this is a situation when you want to understand whenever the general intent of your customer is to buy something in a product or just redirect them to informative page and stuff like that. One interesting thing is that recently we started to see the great joining together of the recommendation engines and search engines, because effectively recommendation engines can be viewed as a search engines. And search engines are, in fact, a bit of recommendation engines. So like the outputs of recommendation engines are usually used to boost or bury products in your search results. So this is very powerful technique which is often used. So, but everything here is mostly revolves around the idea of leveraging what customers are doing with your search system or product navigation system. And that applies to any kind of a system which basically allows to produce results and monitor the clicks or any other signals which you can get from customers. We successfully employed the same kind of algorithms even in the situations of financial companies, where financial analysts are using a particular set of reports, and then you can build a collaborative filtering model which will start recommending a particular kinds of reports for them, because many other analysts are using the same kind of reports in their search engine. So the problem which arises in those kind of systems, like in general, this represents the modern state of the art. This is how majority of mature, well-designed search systems work out there. So this is Boolean retrieval based on the Lucene, Solr, or any kind of proprietary Elasticsearch or proprietary search engines, with a lot of machine learning augmentation on top. The situation when we are analyzing and classifying customer intent, the situation when we are providing a semantic query parsing, basically understanding the portions of a query what we are talking about and trying to match in relevant results in the data. And Sometimes those algorithms even allow you to tackle unknown concepts by statistical means. Because, for example, if somebody search for funky jeans 500 times and they purchased a particular set of products, you can associate then those products with this unknown term. And later, maybe this term can be used to retrieve products when somebody else is finding trying to find the funky jeans. Like, nobody knows what funky jeans is. The situation which I saw in my practice, like all of a sudden after some concert by Madonna, everybody started to search for Madonna dress. God knows what is Madonna dress, so like, but everybody wanted the dress like this. And this drives me to the talk about the next frontier. So what is actually coming? What is coming in the industry? And in our experience, in our view, the next big thing which is going to happen in the community of search engines is the ML-based search. This is not a situation when machine learning is just helping the Boolean token machine to find the products. This is a situation then the neural network is specifically trained to embed both queries and document in the common vector space. And then your problem becomes just a nearest neighbor search in this vector space, which is a well-defined mathematical problem. There is a tiny problem with that, like how do you embed your queries, how do you embed your documents, and all the innovation, all the thinking, and all the innovation in the industry goes in that direction. Because in fact, in this situation, you're not only limited to words. You can use all possible signals about your products. You can have pictures, which can be embedded through convolutional neural networks. You have your attributes, which can be attributed in many different ways as text or as different, like as simple as one-hot encoding or as complex as TF, or a simple TF-ADF encoding. Or you can use all kinds of modern transfer learning algorithms like BERT, which is able to leverage the semantic information from the training of this data on a huge data sets like Wikipedia. And this is when you are getting your hope to start tackling the terms and concepts which you do not have in your data. Because even if you don't have a particular concept in your data, you still can have something similar picked up by these transfer learning models, which were trained on pretty much all the words which exist in English language. So that's the hope, and how you can tackle the out of the dictionary, out of the catalog data. So the key question becomes like, how do you train this model? Yes, deep learning in general is a great thing. It is a universal approximator of whatever kind of function you want to build. But how to train? How to find the training data? It becomes a complex problem. So it starts with the common thinking today is to use a clickstream data to build a click model, which provides you this relevance judgment about how much particular query maps to a particular product, right? And then there is a very powerful, yet like already kind of pretty common approach, which is called triplet loss. Then you are building the training sets with a bunch of triplets. And each triplet is basically an anchor and positive example and negative example. And then you start to look at your embedding. Basically, you start to say, okay, my query is this point in the vector space. Now, this document customers clicked a lot on, and this it looks like this document is very relevant for this query. And the distance is 10. So now then there is a negative sample, which means that our model believes that this vector is pretty close to this particular query. This document is pretty close to this particular query, but nobody clicked on that. It is not relevant. So it is a negative sample. So now let us make a training step. Let us kind of push the vectors which are far away but should be closer. And let's push the vectors which are close together further. And let's repeat it a couple of billion of times. And what will happen? So what will happen is that you will have a semantic search just out of pretty much nothing. What is beautiful about that is previously you had to spend months and months carefully analyzing your data, building your analysis chains, building the indexing schemas, creating all kinds of synthetic fields, which are basically kind of capturing different aspects of the query parsing. You're building query parsers. You have a knowledge graph. You are building all kinds of algorithms which are trying to search a knowledge graph and formulate a very complicated query which you are sending to the search engine and so on and so forth. What you're doing today is you're basically building your click model. And this is a complicated stuff. You have to really kind of excel your click model, because without a good training data, your model will start showing bizarre results. But once you excelled in your click model, you have a power to basically just throw this model and your catalog data and your query logs for several millions of the top, most powerful, most frequent queries in your search logs into the deep learning model, and then put a couple of servers into training mode for, I don't know, 24 hours. And then, as a result, you're getting the model, you are vectorizing all your products and all your queries with your this model, and you're done. After that, you already have a search engine which easily outperforms all the naive search engines out there, and actually works pretty much on par with a very well-tuned search engines of today. And even today, we are sometimes, like, there are problems with that approach as well, of course. Sometimes you have bizarre results which are hard to understand, because it's deep learning after all. It's a little bit hard to interpret. But still, you can always use this model, augmenting your existing search system and delegating the queries to this system which are poorly understood by your own search engine. So that's when you can start to have a real business benefit, and you can attack these famous and fearsome long-tail queries which nobody can understand in the industry. So I think I'm almost out of time. So if you have questions, please see us in our booth. We are Grid Dynamics, doing a bunch of data science and deep learning. Thank you. And yeah, this is a quick recap for all of you, basically, of everything which I said. And yeah, if you remember one thing out of this talk, is that dense search vector is the next big thing, and it's coming. And in 3 years, I believe that everybody will be using it as a commodity search engines. Thank you.